If we'll take the example of, let's say, Ola and Uber is a great example of IoT. Alexa and different Google Home Assistant devices are also a great example of IoT, and we are surrounding with that. I'll tell you another great example here in Bhubaneswar. The city bus is associated with every buses are actually linked to internet, and there is an app by which we can actually visualize the live feed of the bus, that in which station that bus will come and what time it will take to come. So it is very useful, and nowadays IoT making our life more convenient, more enjoyable, so that we can do some other work on that particular time. So I suppose um, I request all of you to please mute yourself so that there will be no disturbance during the presentation. Okay, so once we'll see this, that IoT is the integral part of today's life, let's talk about its proper definition, that what is actual IoT. Now, the IoT is nothing but an ecosystem of connected physical objects that are accessible through the internet. So that we all know that the object, any object, whether it is a living object or non-living object, if that object is connected to the internet, so definitely it is an example of IoT. But this is not enough to actually define IoT. Here we can say the thing can be a person with a heart monitoring system like this we have, or an automobile with built-in sensors. That is also an example of IoT, where thing is the car or the automobile that we have. Object have been assigned the IP address. Definitely, if you want to connect with the internet, we should have some IP address with us. Then only we can connect ourselves to the internet and send and receive the data. But here, these IoT devices actually connected with the internet, and they will transfer the data, they will receive the data without any manual assistant. They don't need a man to be intervene on their work for collecting the data or transferring the data. They will do by themselves. So it is more like automated way of transferring and sending the data to the internet. So here we have some idea about IoT. I'll let you know about some more component related to IoT. So the first component related to IoT is the sensors. So any objects which we want to connect with the internet. Let's say I want to connect my chair to the internet. I want to connect my fan to the internet. I want to connect my light to the internet. So what is required? Okay, so what is required here is we required some sensors to attach. Let's say I want my chair to be connected to the internet. Why I want that my chair should be connected to the internet? Because let's say I want to monitor the chair, whether it is occupied or not. I want to connect my home appliances to the internet so that I can monitor whether it is on or off, right? So for that, I need some sort of sensor. So let's say if I am putting the IR sensor or the pressure sensor into the chair so that I can identify that whether the chair is occupied or not, right? And these are different sensors which are attached, which should be attached with some microcontrollers. So we have some ultrasonic, smoke, human body sensor, temperature and humidity sensor, flame sensor, which will identify if we want to make, let's say, the fire alarm system. Vibration sensors, we have some tilt sensor, soil sensor. There are different type of sensors. We have more and more lists related to the sensor, PIR sensor, which is a motion sensor. We have a RAN sensor. We have different color sensors. So these all are sensors, right? So what the sensor will do is just take the data from the environment, convert into and these data will be given to the processor, which will process and convert it to a digital form and give us the reading. Let's say if we have a temperature sensor, the temperature will be taken from the environment, it will change it to the digital form, and we can see what is the temperature right now, right? So these sensors are very much useful related to IoT. One more thing which is related to IoT and which is an integral component of IoT is actuators. We have, what do you mean by actuator? Let's see. So sensor, what it will do is it will convert the physical phenomena or the analog to the digital and give us the data. Whereas the actuator will actuate or will do some movement to any object. Let's say I want to close the door, right? So let's say I want to close the door and open the door without touching it. So let's say I have an application which is saying that open and close. If I'll put open, that actuator will get the signal to open that particular door, and this actuator will get the signal to close the door. So we have different type of motors available, different DC motor. This is a linear motor, this is a circular motor, and we have some relays also. Relay is useful for the appliances. If we want to make sure that my appliances will work without touching the switch, so I should have these type of relays. So what these actuators are, it is just like your you can understand it is a mechanical thing which is required some energy. So you have to give some energy to this, as well as you have to give the signal. The signal could be to move or to unmove, or the signal will be on and off. So these type of signal you have to provide along with the energy, so that it will give some movement to the object. Okay, so this is the two main thing related to IoT. These actuators and these sensors will actually attach with some sort of microcontrollers. So in IoT, we have many microcontroller available, which is produced by many manufacturers. Here we have some of the microcontrollers. This is called Node MCU. This is one microcontroller in which we attach the sensor and we attach the actuator. We actually get the data from the sensors, and here we do the processing of the data, and here we actually communicate the data to other node or to the internet, right? This is another microcontroller, is called Node MCU. Here also we can attach different sensors and we attach different actuator and we can communicate. This is an ARM microcontroller, ARM. This is a very popular micro or you can say onboard chip or onboard computer is called Raspberry Pi. So all these microcontrollers and the microprocessor are useful in IoT and to enable or to actually make the IoT in existence nowadays. So without this sensors and the actuator is of no use, because these sensors, we should give some energy to it, and then only we will collect the data from that, right? So these devices are very much useful. And the sensor, when this sensor and the actuator is attached with any of these devices, it is called sensor node. And this sensor node will have the capability of sensing, storing, processing, and communicating these data, right? So when we talk about IoT network or IoT infrastructure, so the sensor network plays a vital role on it. Okay, now let's move on to a very important topic of IoT, which is different components of IoT. So let me tell you, IoT is not one technology. It is a combination of different technologies. So you can see here we have different technology which are associated and become the component of IoT. Now here, if you'll see, we have the first component of IoT is thing or device. So anything that we want to connect to the internet, definitely it should be associated with some sensors. And those sensors are attached with the microcontrollers, right? And these microcontrollers will generate the data, and it will make a network of sensors. And this is called wireless sensor network. So this is a major component of IoT, which is called wireless sensor network, because these sensors are attached with anything, any object, right? So that will act as a sensor network, and these sensor network will generate the data and send to the gateway node. And what is that gateway node? Gateway node is a type of computing device you can see, or any of the microcontroller you can see, who has the capability of connecting to the internet. Now this particular gateway node will aggregate all the data, will collect all the data from the wireless sensor network and send these data to the cloud. We all know that what do you mean by a cloud? Cloud is nothing but a computing system or some computing device which is remotely placed somewhere, and we can access these computing device via internet. So this particular gateway device is sending the data to the cloud, means it is using the internet to send its data to the cloud. Because cloud is a computing device, it will have two things to do. The first thing is it will do the storage of the data, and second thing is it will do the processing of the data. Now whatever data will be sent to the cloud, it will be processed through some analytics. Analytics means that if we have a huge amount of data, definitely in the IoT infrastructure, we collect huge amount of data. Is also it will become a big data. So to analyze those big data, we should have some analytics available with us. These analytics are nothing but your machine learning or artificial intelligence algorithms, which will be applied into the data to get some sort of results, right? And these results actually will send to the user through the user interface. Is user interface could be, let's say, if there is a irrigation type of system that we have enabled with IoT, so it will take the soil moisture soil moisture sensor will give us the soil moisture, temperature sensor will give us the temperature, humidity sensor will give us the humidity, and here we do the processing of the data, and based on that particular data will send a message to the farmer that how much water you have to pour on that particular field, right? So user interface could be the SMS, or you can take an example of, let's say, Zomato. So in the Zomato, your where is your food right now? That is associated with the person who actually bring that food to you, right? So that particular person is actually connected with the internet. So you can see your food is actually connected with the internet, and in a live feed you can see where your food is right now. So how you will get it? You will get it through the application, right? Different applications, or you have some web applications. So all those things are nothing but user interface. And through the user interface, user will get to know that this is the status, or from that it can monitor the IoT. So user is using the IoT infrastructure for two things only. One is to monitor, and the second to control remotely. Let's say my whole room or my whole office is IoT enabled. It means I can see in my application that which appliances are on, how many people are inside my lab or the office. So I can easily do that with the help of these IoT infrastructure, in which I am connected with the internet through the application, and I can actually monitor it, as well as I have the facility to connect it or control it. So let's say I want to close the door of my office. I don't want to give access to anyone, so I can close the door here. I give the signal from my application. It will go to the cloud. From the cloud, it will go to the thing or the wireless sensor network, which will enable the actuator to close the door. Or let's say my one of my appliances is on. Accidentally, I have made it on in my home. I can switch it off through this particular phenomena. So you can see that the IoT is not one technology. It is a combination of technology that we can see here. And there are two things or two usefulness of IoT. One, monitoring anything, any object we can monitor. And second, we can actually access those thing or those object remotely. So if we are having any of the useful or both of the work fulfilled, so I can say it is an IoT infrastructure, right? Without these component, I cannot visualize that it is an example of IoT. So that's why I told you these 5 component of IoT, which is very much useful here. Okay, so now I would like to give you a glimpse of this particular approach or this particular component of IoT, in which we have sensor network. There is a gateway, which is an interface between the sensor network and the cloud. Cloud will do some processing with the help of analytics, and it will there is a user interface by which a result will be given to, as well as from the user interface, a user will control this particular IoT device. Yes, so let's go into deeper of that concept and try to understand with some examples. So I think all of you can see me in a bigger screen. So if you can see me in the big screen, it will be good. Now what I am doing is I have some sensors. So let's say I have this sensor. This is nothing but a DHT sensor, which is called digital temperature and humidity sensor. Okay. This is a microcontroller, which is called node MCU. In this particular microcontroller, we have the facility of connecting it to the access point, any of the access point. So I am just attaching this particular sensor to this particular microcontroller. Okay, and what I am doing is I am going to monitor that what is the room temperature and the humidity, and that I can monitor through the applications. So I have made one application, is nothing but a sort of interface here. So let me show you. Let's say this is interface. Here there is 2 text boxes. So I want to am I in the full screen? You can just click my screen. It will come into the full screen, I think. Yeah. So this is an application where it will tell like DHT reading. Here we have 2 things. One is the humidity and another is the temperature. Okay. So I'll show you one. And now I am taking you to the cloud, which is an example here. This is one cloud which is called so this is a cloud. It's called Firebase. It is a Google cloud. Here in this particular portion, you will see the reading of the particular DHT sensor. So I am just putting it on my whole setup, and you can see here, you will see some reading here of the humidity and the temperature shortly. So what will happen is, so here, yeah, the temperature you can see 27 degrees Celsius, and the humidity is 84 degrees Celsius, right? So the same thing you can actually see in my mobile phone too. So if I'll go again into the screen, you can see that uh, the 87 degree, yeah, 87 is the percentage of the humidity, and 27 is the uh, temperature right now, right? So what is that is, this is an example of monitoring, or monitoring the data of a sensor, right? And so that I think you understood. So what I am doing is, this device, this particular device is actually connected with the internet. It is, sensor is generating the data, giving to this device, and this device is sending this data to the cloud, and from the cloud I can see in my application what is that that reading is, right? So this is one example. Another example, you can see that it is one way, right? We can do another way, means can we do can we actually do control that device remotely? Yes, we can do. So behind that you can see there is a setup where there is 4 LEDs. So you can assume that you have 4 appliances in your home, and you want to connect it to the internet. So these 4 appliances is connected with the internet, and these appliances you can actually control through your application. So we have an application which have 8 buttons, and it will tell us, okay, you cannot see the LEDs is just behind me. Okay, just behind me here we have an LED. You just make it a big screen and you can able to see that. So so now I'll do is, I'll connect this particular to the internet, and let's that particular node will be connected to the internet. It will take 2-3 seconds of time, and then you can see that how it is uh, controlled by me. So what I am doing is, there is a green button. I am just pushing one green button here. You can see all my lights are on now. All 4 lights are on, right? And let's say I am putting some red buttons here for making it off. Slowly it will be off, right? So this is another example where we can control any of the devices through anywhere in the world, right? So this phone is connected to the internet, my setup is connected to the internet, and we have a cloud. So I am sending my signal to the cloud. If you want, let me tell and show you where I am sending the signal. So I am sending it to the cloud, and I'm just putting into that particular screen. So you can see here, this is yeah, so this is a cloud here. Here all these variables are associated with each one of the LEDs. So you can see S1, S2, S3, and S4. And when I'm putting it on, so you can see that it will be 1, 1, 1, and my LED is on, right? So it will be off, 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 means 0, 0, 0, and my LED will be off, right? So this is so simple to make, and is very good to actually understand what do you mean by IoT, and how you are saying that what is an IoT. So this is how we can visualize an IoT. Why I am telling you is, this is, without visualizing, without seeing that what do you mean by IoT, you cannot understand the inner way of IoT, and whatever I'll tell you, it will be very difficult, right? So let's go again to the presentation and try to understand a different thing related to IoT. Yeah. So all these components we have just seen, right? We have the cloud, we have the gateway, we have the sensors, we have the user interface which will do some. And here we are not actually using the analytics will be done by the cloud, where it will do the processing of 0 and 1, and it will convert the 0 to off and 1 to on, right? So this, or if you want to do analytics, you can do it very very easily. So one example I have given you, the cloud is Firebase, which is a Google cloud. You can take Amazon Web Services, where we have different IoT clouds available.
Hello,
You can take.
hello, 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 hello.
Okay, so there is a disturbance, I think. Okay, so yeah, you can visualize all those things that I have just told you, and you can do by yourself. Let's go to some applications of IoT. So without the application, what is the need of it, right? What is the need of any technology? So there is no need of technology without its application. But IoT has a huge application and tremendous applications in the COVID pandemic also. So yesterday we have a discussion on different IoT application of COVID-19 pandemic situation, that what are the different applications that are useful. Definitely it will come into the YouTube shortly, within days or two. Okay, I'll share with you the link. So let's go to the application of IoT. We have a smart home, right? We can make our home smarter. We can connect everything to the internet, and we doesn't have to touch the switch to on and off. We doesn't have to touch the remote to say to change the channel, right? I can do with the Alexa, or I can do with any Google Assistant system by just saying it, or by using the mobile application. We have very many variables like this particular smart watch, which will have different sensors actually, right? So it will just monitor my heartbeat very easily. It will monitor like how much walk I have done. If there will be a temperature sensor, then it will give me the value of what is the temperature of my body, what is the condition of my oxygen level in the blood. All those things can be very much useful in today's life. Smart city, there are huge application of a smart city, from the smart transportation system. Just now I told you, in the Bhubaneswar we have a smart transportation system, which is the bus which is connected with the, and we have the application. We can actually real time monitor that particular thing. We have a smart signals available with us. We have all the transport system are connected with the internet. Street lights are connected with the internet. You can see the garbage system. You can make an application of IoT, waste management system, water management system. Then we have another example of a smart grid, which will make your electricity distribution system more smarter, right? So all those things are nothing but the example of IoT. Industrial internet, that is also called IIoT, industrial internet of things. Industry are using different applications of IoT. They are connecting their machines to IoT. They are connecting their chambers to IoT. They are having different sensors which will find it out. Do we have any poisonous gas on that particular chamber, where it is very risky to go? Is there any leakage of the gas? What is the power consumption in that particular area? All those things are very much useful in industrial IoT, which is called industrial internet of things, right? It is also, in today's world, there is industry 4.0. It is also an example of industrial IoT. Connected car is another example of internet of things, which is called internet of vehicles, IOV, where all the cars are connected to each other, by which we can make the autonomous car. So many companies are working on autonomous car. It is a driverless car. So that is also an example. We have connected health. We can make many hospital which will talk to each other. If there is some accident, it will inform nearby hospitals. They will send the ambulance in the emergency. They will exchange the diagnosis information of the patient, and from that they will be benefited. They will make the ledger of those uh, the health ledger of any particular person. So if anybody will be gone to any of the hospital, it will find out what is the health issue he has, right? Smart retail, right? We can have these smart retailing system with us. Smart supply chain that we can do. Smart farming. So all these are different applications of IoT. This application is not limited. There are many other applications that we can have in IoT. Let's talk about the topic that we are gathered today is different challenges related to IoT. Now, according to Internet Society, they have recently published 50-page of white paper examining the opportunities and challenges associated with IoT. So I will talk about challenges here. The first challenge is security. Why why they have taken this particular thing as a challenge here is really security is a challenge to IoT. So we'll talk about it. Security is an essential pillar of internet, and one that ISOC, which is Internet Society, perceive to be equally essential. And the most significant challenge of the IoT is security in today's scenario, because everybody is looking for different applications of security without actually looking for the security aspect of it. Privacy is another concern in today's life. Let's say if I'll take the example of Alexa, and I have, let's say, Alexa installed with me. So if I'll say, Alexa, what is the temperature for today and what is the news for today? So when I'll say Alexa, it will be command will be activated, and after that what I'll say, it is a command to the Alexa. But what Alexa is doing in between, actually it is listening to me, right? Whatever I am saying in front of the Alexa, it is listening to me, and where that particular data will go, it will go to the Amazon web server. If we have a Google Assistant, it will do the same thing. So okay Google, before saying okay Google, I can say many things in front of this particular device, and these this data will be going to the server of the Google, and it will find it out what I have said. So if we have some, let's say the secret meeting is going on, or some private conversation I am doing, it is going in the cloud, and these people can see my conversation. The same thing is happening with your mobile phone also. So in the mobile phone, Google has all the information related to your location for the last, let's say, 1 year or 2 years. It will know that at that particular time, where were you? Yes. So that's why they will ask you, let's say you went to one restaurant, and after that they will ask you to give the review of that restaurant. Why? How they can get to know about it? Because your mobile is enabled with that particular location system, in which the Google will easily identify where were you, and they will ask the review about that particular place. Why? Here, this mobile phone is a breach to your privacy, actually. Yes. So all those are different aspect of privacy breaching, you can see. And this is a major concern in today's life. Another thing is standard. A standard is a challenge, because IoT till now, for all the IoT devices, what I have given you, the sensors and the microcontroller, there is no standard till now. There is no standard till now. Okay. Regulations also. So there is no regulations related to IoT, how we are looking for the privacy, how we are looking for the security. There is no regulation written. So that's why these are all are challenges related to IoT. Now let's talk about the security aspect of IoT by looking for all those different components. So we have seen 5 components, right? So we'll see where the security portion will be come up, and we'll see what are the different issues, what are the different attacks, and how we can actually countermeasures those attacks and those issues. So we'll see that in later slides. So before going to that, let's see what is the need of security in IoT. As I told you, that there is no standard, there is no particular infrastructure that has been made to make any company to be enabled with the security in the hardware, right? As well as we are using the software in these devices, which are also not at all secure. So you can see this particular survey where it says that a full 98% of all IoT device traffic is unencrypted, exposing personal and confidential data in the network. This is a big concern. So 90% of the IoT traffic is unencrypted. We are not encrypting the data which is flowing actually into that particular network, which is generated by these sensors. And it might be your confidential data. Let's say if you are using a smart camera and you are monitoring your home, and let's say this particular system is not secure, so anybody can hack the smart camera and can see your home in a live, right? So that is easily can be done. Your smart camera is an example of IoT, right? So this is a very big concern. The second concern is, if we have IoT infrastructure which is having a particular application specific where we require security. Let's say we'll talk about uh, talk about the Alexa and all, where we required security, means all the data that is going through that particular Alexa should be secure all the time. Or you will take the example of we'll say have some example. Let's say in the border area of, let's say, Indo-Pakistan border, there is motion sensors, right? And these motion sensors are generating the data and sending it to the nearby base station where there will be a processing and alert is going on, right? So if that particular system is vulnerable to different attacks, so we cannot get mm, the good reading of that particular infrastructure. If we'll talk about the industry is manufacturing, and the cost is very high, and if some hacker will hack that particular any of the industry IoT device, so it can do anything with that, right? So all these are the concern. That's why the security is very much useful, or security is required in IoT infrastructure. Now, as I told you, we have a component which is a wireless sensor network. And this particular component is very much useful. Why? Because it is working in the ground. Means in the ground level, it is actually dealing with sensor and actuator. It is generating the data. It is getting the data. So data transmission is very much going on in that particular component. So this is the first component where we'll see different attacks, and we'll see how we can countermeasure or how we can give security solutions to these this component, which is a very much component of IoT. So in this particular wireless sensor network component, the attack is divided into two parts: passive attack and active attack. Passive attack means actually we are attacking the device and a user will get to know that there is an attack. But in the passive attack, we do not disturb anything, or we do not disturb the normal processing of the network. Instead, without doing that, how we are getting the data? That is the passive attack. So the first passive attack is eavesdropping. Eavesdropping means if I am in the vicinity of any of the sensor node, what the sensor node is doing is they are collecting the data, sending this data to another sensor node. This sensor node are again sending and relaying this data to the another sensor node and send to the gateway node. And that gateway node is connected to the internet so that it will send to the cloud. But the communication between two sensor nodes, if some attackers is coming into the same channel, it can easily find it out that what is happening or what sort of communication is going on in between two nodes, right? So that is one type of attack. Second is node malfunctioning. So node malfunctioning can be done from the manufacturer time. So at that particular time, maybe some device is malfunctioning or some devices are not working properly. That is also, and the attacker can make it like a node will not do the work properly. If some node is assigned to send the data but it is not sending the data, it is also a node malfunctioning. Node outage. Now node outage is happening due to the lack of the energy. So if a node is, because all these sensor nodes or all these applications are, let's say the application which I told you, the motion sensor application in the border area. So do you think that we have the power in that particular area? No, we doesn't have the power. Instead, we provide the batteries of these sensor nodes. So there will be a chance where these batteries will be exhausted and your node is not working properly. And that particular node is, let's say, a cluster head node, which is collecting the data, but it is not working properly. So it is an attack which is called node outage, or you can say it is in between the routing path, but it is disturbing the routing path by not working there, right? So all these are an example of attacks related to node outage. Then there's a traffic analysis. So any attacker will analyze the traffic and get to know that in which particular area more data flow is going on, because the node which is near to the gateway node is flowing more data, right? That is happening. Why? Because that node which is near to the gateway node is sending more data. Why? Because it is collecting the data, and because it is nearby to that, it is sending more data. The same way will happen to the cluster heads. The same way to happen to any other nodes which are having the more responsibility. So it will find out that particular node, and the attacker will attack that particular node through traffic analysis. These all our attacks comes under passive attacks. Then there is some attacks which is called active attack. Means a user can know that attack actually happened. So first attack is called collision attack. So in this, attacker will come into in between sender and receiver, and it will what it will do is it will send its own signal, so that the signal which is going on between sender and receiver will be collided, and sender and receiver will not receive any signal. So that is a type of attack. Spoofing, another type of attack, where a malicious node will find out the MAC address of a legitimate, or the, you can say the target node which he want to do attack, right? So it will get the MAC address. How it will get the MAC address? By ARP spoofing. We all know that what do you mean by ARP spoofing. From the IP address, it will get the MAC address, and that MAC address, it will find it out the MAC address of other person and act it like that particular person. So here there is a node has the MAC address, and this MAC address will be with me also. So I perceive like other node, right? So that can happen in the spoofing attack. Then there is a hollow flood attack. In the hollow flood attack, what happens is, when your sensor network infrastructure will be deployed, so at that particular time, each node will not know what are my neighbor node. Okay, so for that, the first thing any sensor network will do is it will send the hello packet. So the hello packet will go to the surrounding of the node, and whoever node in the vicinity of that particular node will receive the hello packet and find it out that that node is my neighbor node, so that I can send the data to my neighbor node, and that neighbor node will send slowly my data to the gateway node, right? But what happened in hello flooding attack? Attacker nodes will send this hello packet in such a way so that everybody will find it out that that particular node is a neighbor node. And what they will do is they will send their sensitive data to that particular attacker who want to be your neighbor node by sending this hello flooding hello packet. That is a hello flooding attack. Then there is hole attack. There are different hole attack, which is categorized into black hole attack, sinkhole attack, selective forwarding, and wormhole attack. Let's see one by one. What happened in black hole attack? Let's say if some nodes are, some attackers node are in the root of the routing path. Okay, there is a routing path. So if source node is sending the data, it is slowly going, relaying through the nodes and going to the gateway node. But in between, let's say there is an attacker. And this attacker, what it will do is, in the black hole, whatever data is sent by the source node, all the data will be dropped by that particular malicious node. That type of attack is called black hole attack. Then there is a sinkhole attack. In the sinkhole attack, a node will persuade like I am the gateway node, and so every node will send the data to that particular gateway node, which is actually the attacker. Then there is a selective forwarding attack, in which the node which is the attacker node which is in the root will send some of the data, forward some of the data, and drop some of the data. So some of the data will be dropped and some of the data will be forwarded, so that we cannot identify that attacker node very easily. Then there is a wormhole attack, in which two nodes are persuading like we are the shortest route to the sink node, and these two nodes are making a tunnel, is a wormhole, in which if a source node will assume that from these two nodes, if I'll send my data will reach to the gateway node as early as possible, because it is the shortest node. So that is an attack which is called wormhole attack, right? There is a Sybil attack. In the Sybil attack, a node will act as another node, or will act as a legitimate node in the network, but that node is an attacker node, which is called Sybil attack. It will find out or act as a legitimate node, but it is an attacker node. Then there is an attack which is called MQTT exploit attack. MQTT is actually a transmission protocol. It's called Message Queuing Telemetry Transport Protocol. It is a lightweight transmission protocol which is very much useful for the low power devices like sensor nodes. So MQTT is a replacement of HTTP, okay, hypertext transmission protocol, because the header and the trailer of HTTP is high, but in the MQTT it is using a public subscribe phenomena. That's why the size of that particular header is very less in MQTT and very useful in IoT communication. Then there is a denial of service attack. We all know that if attacker will send some bogus information again and again to the device, so that that device cannot serve anything. So it is the attack to the availability of that particular device, and the device will be unavailable to do any of the work. So that is the denial of service attack, which is part of the active attack. Now, all these are the attacks, and let's see the countermeasures. So how we can countermeasures all those type of attacks. First of all, we have to use some encryption algorithms, right? We should have some encryption, and that encryption algorithm, we should have some shared key in between the sender and receiver, and that encryption scheme should be lightweighted, so that these devices will use the lightweight encryption process and actually do the encryption, and then the receiver will decrypt it. there should be some authentication scheme. Authentication scheme means we should know that if we are receiving the data, so that receiver should be authenticated. And if I am sending my data to anybody, so that node should be legitimate. So to finding out the sender is legitimate or to finding out the receiver is legitimate, there is the authentication protocol which will authenticate each other. After that, there will be the data transmission. So both will get to know that both are legitimate so that they can send the data. Then there is a random key pre-distribution. So key distribution will be done, but it should be a random one. And there are different schemes or different algorithms by which we can do that. Or you can use some anomaly detection or this IDS, intrusion detection system, where you can find it out, is there any node which is acting maliciously or it is acting as an attacker. So we can use some of the IDS protocol, that is intrusion detection system, based on the anomaly, we can do that. Or we have to use some public key encryption algorithm by which we can actually reduce those attacks which is happening in wireless sensor network, which is a part of IoT. So you can see that to secure our IoT infrastructure, we can use some of these solutions according to our application. Then there is another part of IoT which is called edge computing. Okay, and this edge computing is nothing but, you can assume like there is a gateway node, right? This particular gateway node is nothing but collecting the data, and because that gateway node is connected with the internet, it is sending the data to the cloud. Yes, so that particular gateway node is acting as a edge computing node also. So if we need to process the data, and these data is very sensitive data, I have to process it in a fraction of time, I'll use local computation power of that edge devices, which is in the edge of the network. You can see that it is an interface between the wireless sensor network and the cloud. So that edge node has the capacity to do the processing, give the result in a fraction of time, so that we doesn't have to wait for the cloud to do the processing and send it, because the delay will be less when we do the edge computing, as well as the bandwidth will be less consumed. We are not sending all the data to the cloud. We are just sending the data to the cloud, which is non-sensitive data. Okay, so that thing can be easily done with the edge computing. Actually, for every application, we do not use edge computing. For some of the applications, we use edge computing. So I think you understand what do you mean by edge computing. Edge computing is nothing but there is an edge device. You can see the gateway node is an edge device, and this gateway node has the power, has the processing capability to process the data which has been received locally, so that the latency will be less, means the time will be less for the computation, so that we doesn't have to wait for the cloud, as well as we can reduce the bandwidth of the network. So in edge device also, if you're using edge computing, what are the different attacks and what are the different security concerns are there? Let's see one by one. So the first concern is eavesdropping. Here also we have the attack that can be possible. The attack, same attack which is we have seen in the wireless sensor network. We may have denial of service attack, right? So this particular edge device can be unavailable by if attacker is sending the bogus information again and again and asking for the authentication, let's say by giving wrong credentials. So definitely it will, what edge computing will do, it will authenticate it. It will just say that whether your username password is correct or not. It will involve its all the resources to that particular thing. So other thing cannot be done by these edge devices. So it's a very Good example of attack, denial of service attack. Data tampering attack can also be done in these edge devices. Data can be tampered, result can be tampered, right? Insecure communication between devices. So if we have this edge device and we want to send these edge device data to my sensor node, or from the sensor node to the edge device, so in between there is a insecure communication. Recovery and backup of data during the system outage. Let's say if that edge device has been collapsed somehow, is malfunctioning somehow. So how we can recover or from that particular data, and how we can take the backup of the data. So these are all different security issues and the attacks related to edge computing. And there are some solutions, like equip all edge node with the same level of security in the network. Encryption and access authorization of data could be done. So encryption as well as access authorization, means encryption and authentication both could be done. We should have some intrusion detection system in that also. We should have the lightweight in cryptographic algorithm. We have to use the lightweight, and we have to use the behavior profile. So user behavior profile is also a main thing. Let's say a user is using the application, let's say locally, and let's say switch off and off the on and off the appliances, off, on and or open or close the door. So that behavior would be taken by the edge, and based on the behavior, if some other behavior will be taken place by the user, so it will deny that particular commands, so that we can actually reduce the attacks here with this particular technique also. So this is all about edge. Let's talk about cloud, right? So we know what do you mean by cloud. So cloud is nothing but a computing device, or you can see a computing system which is located somewhere remotely, and we are accessing it through the internet, right? In the cloud, we have some services. Services started from infrastructure as a service, platform as a service, and software as a service. So in the infrastructure as a service, the cloud service provider will give us the hardware and the networking part. They will not give you the operating system. They will not give you the application, system application and different application. That you have to install and you have to do all those things. That is infrastructure as a service. Second thing is platform as a service. So in the platform as a service, they will provide you hardware and the networking along with the operating system and some application program. Data and the processing of the data will be done by the user. That is platform as a service. Then there is a software as a service. In the software as a service, they will not give you any infrastructure, physical infrastructure. All will be managed by the cloud service provider. All operating system, all application will be done by the cloud service provider. Instead, they will give you a thin client which you can install your user and password, and you can use the softwares like Oracle. If you'll go to the oracle.com, you just use your username and password, and you can use Oracle SQL. You can create the tables, you can do SQL thing, right? Or you can take the example of PUBG. So PUBG is an example of software as a service, where a thin client application is installed in the computer of a user. User will give his username and password and connect to the cloud, and it will use the PUBG game, right? So this is a cloud application. So let's see what are the different security issues and the attacks that is possible in cloud computing. So the first thing can be done is denial of service attack. Like a user will give its wrong credential all the time, and that particular service can be unavailable for some time. That can be done actually. Injection of cloud malware. Let's say I have a cloud infrastructure and I am the attacker, and I am injecting some malware in that particular virtual machine so that I can get the information of other people. Communication interception, that can also be done between two virtual machines. What type of communication is going on? that can be seen by the attackers. Data thief by malicious user in the system. So because we are using the cloud, and this cloud are of actually two type, public cloud or private cloud. So public cloud is public to all. So all these type of attack can be done in the public cloud, right, where many people are using the same infrastructure and they are creating their own small machine with that particular infrastructure. So data thief by the malicious user can also be done. Absence of secured software development process by the cloud service provider. If there is this is a security issues. The other security issues are recovery and backup from the system failure. If the system is failed, then how we can take the recovery and the backup. Inefficient authorization and authentication. If we doesn't using good authentication and authorization service, so your cloud is of no use. An attacker will attack the cloud and will down the system. Data loss and data breaches, that how we can recover from the data loss and data breaches in the cloud. So all these are different attacks and the issues. So how we can overcome this? So we can overcome by monitoring the network, especially with the different firewall systems, and encapsulation of access control policies. So we should have some good access control policies. We should have the implementation of firewall so that we can monitor the data which is incoming data and outgoing data into the network. Authorization enforcement for admission requests, that authorization we can provide. Encryption of the user data, whatever the data that I am putting into the cloud. Let's say if you are using the Google Drive and you are putting your sensitive data into the Google Drive. So in the Google Drive, do that particular data is in the form of plain text or ciphertext, means it is encrypted or it is unencrypted data. So it should be encrypted data into the drive also, because we are using the resource pooling in the cloud. So one resource will be pulled by many people, right? So any people can access my data. If he is an attacker and knows about pointers and all, it can go into my area of the hard drive and can see my data. Recovery facility should be there from the data loss and all. So all these are the different security issues, security solutions of those attacks and the security solutions. So we have seen different components, right, which is useful in IoT, and we have seen different attacks and the security solutions to that. We have some open issues. These are all research issues. These are all open issues related to it. The first issue is IoT cloud integration problem. So we have done the IoT cloud integration, right? So these IoT devices is connected with the Google Cloud, and if I am sending the command, the cloud is sending that command to it. It is very easy if we have a less number of data. If we have a more number of data, and if we talk about the big data, so the IoT is generating a huge amount of data and it is stored into the cloud, processed into the cloud. It will take a lot of memory, lot of processing power, and it will become the problem. So we should have set up our cloud in such a way so that it will handle these many traffics, right? The wireless communication security. So all these IoT devices are using wireless communication, and all the level of security in all the level of this TCP model should be there, from the physical layer to data link layer to transport and this network level and that application level. So in all the layers, we should have security concern. Interaction with IIoT or cyber physical system. So interaction of industrial interactive thing and cyber physical system, the demand of these sensor devices, demand of these IoT devices are more, right? So manufacturers are manufacturing these devices without the standard. There is no specific standard, and these unstandard devices are used by the factories, used by the industries, and it is very harmful to the attack, right? So these are different open issues related to it. We have some additional security solutions. okay, related to IoT. One is blockchain. We all know what do you mean by blockchain. Blockchain is nothing but a distributed ledger where there is a distributed system which will have their own block chain of blocks. If any transaction will take place, that block will be attached to the blockchain after the authentication of this particular transaction. Blockchain is immutable ledger. Immutable means we cannot change, or it is you can say a great example of maintaining the integrity of the data. So can we send these data into the plain text, or can we send the data to in an encrypted form? That is another concern. But blockchain will make a transaction ledger with the help of hash values, by which we cannot change any of the block, or we cannot change the any of the transaction which is going on. And it's very much useful in internet of medical, or you can see internet of health, IHOT or IMOT, right? Where these medical data and these health data are very much sensitive data, and that cannot be changed. And for that, we can use blockchain for securing into the cloud. We can use a different key distribution system by which a distribution can be done very easily and very efficiently and secure way. We should have some trust management system by which we can get to know that which particular node is doing some malicious thing and which is not doing the malicious thing. So trust management system we should import. Independent link padding we can do to remove the problem of traffic analysis. We can use some padding into the actual data so that attacker cannot understand what that data is. It's very easy to actually confuse the attacker. Secure data aggregation at the time of let's say the gateway node or the cluster head which is actually aggregating the data. Can we make the data more secure by encrypting it? Patch management. If any sensor node, because these sensor nodes are embedded system, every hardware is associated with the software, and when we get the software update, we should update all the IoT devices which we have, right? If we'll not update the patch, or if we'll not update the software of it, there is the probability of attacker to attack. Another is automated fingerprinting. Whatever users are using that particular IoT infrastructure, we can make a fingerprinting out of that. And from that, we can get to know that if there is an attacker in the network or not. So all are different additional security solutions related to IoT that we can use. In the conclusion, I can say that IoT is a large-scale, complex architecture design comprise a variety of heterogeneous devices, right? Therefore, scalability, transparency, and reliability are most prominent milestone to be achieved. So why we are using IoT? We know that it should be scalable. We know that it should be transparent. We know that the IoT infrastructure is reliable. That's why we are using it. But without any security, without the concern of security, these milestones cannot be achieved, right? So that's why the security is far more important in the IoT infrastructure, so that we can make the IoT infrastructure to be useful for everybody, hassle-free, so that people will enjoy this technology and they will use this technology and they will get the benefit from this technology.